in day 2, session 2 of the faculty development program on big data analytics using Python. The second session of the day would be taken by Dr. Sushma Bahuguna. The session is on big data batch processing algorithms and graph data analysis, which is very important aspect being used in research nowadays. Dr. Sushma Bahuguna, she is working as a senior assistant professor at BCIIT. She has obtained her graduation from Pune University, BA degree from Bharati Dasan University, MCA from MDU, Rohtak, MTech degree from GTS IPU University and PhD from Zingania University, Rajasthan. She has more than 23 years of experience in teaching and research. She has contributed many research publications in peer-reviewed journals and many more to add to it. She is an IBM DB2 certified professional. Her research area include speech processing, databases, and signal processing. A very warm welcome to you, ma'am. Let's begin the session with her. Over to you, ma'am, now.
Thank you, Sonia. Am I audible? Am I audible? Okay. Thank you for the introduction, and I also thank you for providing me this opportunity for taking the session on graph processing and batch processing algorithms. Now, today's session, I'll be focusing on a hands-on session on graph processing, graph database, how do we create it, how do we maintain the graph database, and how the data is actually stored and processed. And also with that, how the visualization will be taking place of the graph data, of the data which we are storing in the form of nodes and edges, how the presentation could be done using various APIs which are available. We have Python APIs, we have other APIs which are available for visualizing the data. So I'll be focusing more on how to actually store the data, how to store the graph data, and how to actually process the graph information, and how we can process the graph information. So just confirm if the slides are getting shared. So are these slides visible to all? Okay, thank you. Now we are we have been taking this session, this online FDP since yesterday, and we had an introduction on what is big data and how the data is getting processed. The sessions till now had covered the meaning of the big data processing, what are the steps involved, how we actually are processing the information, and how we are getting certain meaningful information from the various stages of the data processing which had been which is taking place. So now we are more focusing on, instead of data processing, we are moving towards the analytics also. The analytics is basically finding facts from the processed data which has already been processed, stored, and stored in various devices, and from there we are actually accessing the information, finding certain facts, interpreting the facts, and interpreting it to certain meaningful patterns which are derived from the patterns which we are already storing. Now, next is big data analytics. Since yesterday, we had seen these diagrams a couple of times. Like we have data available in the form of structured data, semi-structured data, and unstructured data, and the meaning have been made clear by various speakers, which had taken session since yesterday. Now, the data generation part, the sources of data is the main important part here. Like in big data, the data generation is one of the basic thing from where this particular term has arisen. Now, today we have the data getting generated from various social media platforms, from customer feedback, surveys, text messages, emails, call centers, ATMs, structured data, and if we talk about, like, we have many PDFs which are available. One is the result PDF. We have the result of various colleges in one PDF containing the data of all the students securing a particular marks in a particular course. And similar to that, like, these are all the sources of big data. We have social networking sites, we have e-commerce sites, weather stations, telecom companies, share markets. These are the various sources of big data, and these are a few to mention here. We have many other sources which are available. The data which is available, we have a large volume of data with a variety of information, variety of file formats which are there. The velocity, the speed at which the data is coming, the value we will be extracting from the data. We have the validity and veracity. These are all the, we can say, 5 V's of big data. Now we have other couple of V's added to it, and I was just researching, and it was like 8 V's of big data, which was listed out somewhere in certain sites, websites we were navigating. Now, next we have the amount of data getting generated. These are the, this is a picture which had been taken from one of the referential sites, and this is of 2020. Now we are in 2023, so this figure might have changed, and it has actually changed, and we all are witnessing the amount of data that is getting generated here. Now, in today's slide, today's presentation, I'll be more focusing on the graph database and how we are actually working on the graph database. Graph database actually is basically more useful in certain use cases that has been mentioned here. And we will be having an hands-on session on SQL Server for graph databases. We'll be using Apache Spark, the graphics library of the API of the Apache Spark library. We have NetworkX, one of the Python libraries available for visualization. So let me start with the first one, the SQL Server for graph databases. So how do we maintain the graph database? So every graph database, you will be noticing that we have the graphs comprising of the nodes, edges, and certain relationships between the between various nodes which are connected using the edges, and stating certain relationship between the information which is presented in the form of nodes. So each node represents an entity, a person, place, thing, category, or other pieces of data, and each relationship represents how two nodes are associated. Nodes are also called vertices or points, represent the entities for which we are finding the relationship for, and edges, also called links, connects two nodes when a relationship exists between them. Now, so a graph consists of nodes and edges. Nodes, sometimes called vertices, vertex, and we have already discussed what all could be a node. A node could be the information about a person, a city, a employee, customer, or any other data you are thinking of. Edges are used to map the relationship between the entities, like we have two entities mentioned here, a person and a city uh, node which is mentioned here. So there is a relationship existing between a person and a city. Maybe the person is working in a particular city, a person is a resident of a particular city, a person might have visited a particular city. So these are all the relationship that could be represented in the graph database. So graph database are well suited to things like supply chain management system. Graph database have also proven efficient to develop recommender system where the relationships like person who bought item X also bought item Y. So these are the recommendation systems we are already hearing of, and the students are also working on such projects. So one of the graph database example, the Twitter is one of the best database example we have here. Twitter is a perfect example of graph database connecting hundreds and of millions of monthly active users. So we have many users on Twitter, and there are certain relationships between the users, and we can represent the Twitter users Twitter database on in a graphical representation in the form that has been presented here. So we have nodes, the users, the actual users are the nodes, the edges connecting to users, and the relationship being shown between the users. So user one could follow another user or could be reversely followed by the next user also. So this is one of the examples of graph database. Now let's start with our hands-on session on working with graph database. For this, I have installed SQL Server 22. So SQL Server 2022 uh, and also the SQL Server Management Studio has been installed on my system. For this, as we have already discussed, that every graph database is represented in the form of nodes and edges. So in SQL Server 2019 onwards, we have the graph database explicitly added to the SQL Server, and we can maintain the data in the form of nodes and edges, which I'll be demonstrating here. So we have the nodes created as firstly we have to create a database wherein we can store the the other objects of the database. We can create a table as a node. So here we will be specifying as node with the create table statement. So we have the command as create table name. Then we have the set of columns which we want to specify, which we want to add to the table, and we need to add the as node clause at the end. So it will be creating a user table as a node added here. Next is we can insert data into the table as we have been doing in other relational database management systems. So we have the SQL insert statement which is used here. So insert into users, username, values, certain values has been mentioned. Insert into table name, the attribute name, and the values here. So when I created the table here, I had mentioned the user ID as the identity column. So I'm not mentioning the user ID. It will automatically be generated as soon as I start creating the, I start inserting the information into the table. So we have 5 rows getting created into the table here. Once this is done, I can also check if the object we are mentioning here is a node or an edge. So for that, we have a command select is node is edge from sys tables. Sys table is the system table where the name of the object is the user's object we had just created. So from the user's object, it will be fetching me the information whether this particular object is a node or an edge table which we had created. Similar to this, we have other nodes created. So once the nodes are created, we have the create table statement, create table as edge. So here we have the create table statement mentioned as create table name as edge. So this particular table will specifically be storing the information about how the what is the relation or how the what is the relationship between the between two nodes. So we will be seeing what is the insert statement, how we can store the edges, how what data we need to store into the edges table. That also we have a command here. Now we have created certain tables. Now to insert into the edges, we have the same insert statement with the table name mentioned, the table name mentioned here, and we are also using two attributes, that is the from ID and to ID attributes to which the value will be stored. So we have the edge table created with certain attributes added to it. So we have the from ID and to ID attribute here. In the from ID and to ID attribute, we are adding certain values to this. Is my slide visible? Can you please confirm which slide is getting displayed?
It is optical.
Okay, thank you so much. Okay. So here we have insert into the table name. We have inserted 3 rows into the likes table, wherein we are specifying the relation from which ID is liked by which the second user. So here we have it implements the like relation between user ID ID1 and the team ID ID3. So it is the team, the user liking a particular team. Similarly, in the likes table, we have the user ID2 liking the team 4, and we can also have multiple out degree relation. We have user 1 could like another team also, so we can insert as many relations over here as possible, and if there are relations existing, we can create the relations here. Now let me give you a demonstration on how we are actually working on the graph database. Okay, here. So we have started with the SQL Server Management Studio, and firstly, let me add a new database to it. I'm giving the database name as some name to the database. Okay. So you will find the database has been added, but there at present there are no objects existing here. So we don't have any of the table objects or any of the objects which are existing here. Now you will notice that in this table object, we have a graph tables appearing, and whatever graphs we are adding, whatever database we are adding to the graph database, it will be added to the graph tables. The list will be added to the graph tables over here. So let me start with the creating of the nodes. I have already created the SQL files. We'll be sharing these files. So drop table command is actually checking for the table. If it is already existing, it will first drop it and then go for creating the new instance of the table here. So create table users, user ID as identity column, user name. You may also specify, if you are not making it an identity column, you may also specify your own values to it while entering the information. Second one is the teams table. Third one is the stadium table, and fourth one is the city table, which will get created once I execute these set of statements. So to execute these set of statements, we have either we can press the F5 key or the execute statement from here. Okay. You can notice that I have created a table. Now tables have been added here. Once the tables are added, we need to enter records to them. So we have the tables added with the fields we had mentioned in the graph database. So these tables are added as nodes. If we want to test the node, we may provide the command So let me check the cities table created here is a node or a edge. So for this, now the output here, it is displaying as the table has been added as a node. It is not an edge. Similar to this, we will be creating other tables. We'll be inserting information into the table. So let me open the file for inserting into the nodes. So now we have users table, teams table, stadium table, and cities table mentioning certain data. Let me execute. So I have a simple insert statement. So we have the data inserted into the nodes, node table. So for inserting the information, for inserting the data into the nodes, we have the insert statement. The SQL insert statement will work, wherein we are storing the information in the username field. We are mentioning the username field and specifying the names of the users which we want to create. Similarly, in the teams, we have one attribute, team name. To the team name, we have the value added. Similar to this, stadium name, we have certain stadiums added, and then city names, we have certain cities added. You want to test whether the data has been inserted or not, you can simply use the select statement. Select. So you can notice that we have the list of cities which we had inserted is appearing here with with the city ID automatically generated for each city. Next, let us create the edges. So for creating the edge, we have the create edge command. Similar to the create node, we have create edges command. So in the for create edges command, we have create table, table name as edge. So it will be the table object created as edge, and we have added 3 edges here. Let me execute. So the command is successfully executed, and you will notice, just refresh your Object Explorer window. You will notice the edges has been successfully added. So yes, so we have the edges added to the table, to the graph tables. To insert the data, let me open the insert statements. Insert into edges. So here, the first three statements are inserting the edges into the likes table. So insert into likes. Likes is an edge. So insert into this edge, we have the from ID and to ID attribute of the edge table, which is automatically defined as soon as we create the table as an edge. Let me execute this and check. So we have the edges inserted into the table. Let's see what is the content of the table here. So instead of cities, I will just say likes. So we have two edges inserted here in the likes table. Similarly, we'll be inserting the values into other edge tables. So we have home stadiums and we have stadium cities, which are added here, and it is comprising of the from ID and to ID. It is actually specifying the relation which ID of the first table is related to which ID of the second table. That is mentioning in the insert statement. So similarly, we had inserted the values into all the three tables of the edges. To select the data, we have the select statement. So select the username, team name from the table names we are mentioning here. Okay, and here we are mentioning the match attribute here, so not attribute, match clause, wherein we are mentioning the actual username. Sorry, actually which user is related to which other user and what is the relationship there. So when I execute this, let's see. Okay, so the first user is, the relationship is being shown here. Similar to this, we have other relationships which will be appearing. There is no related information as per the value I am mentioning here. Check this. Okay, so we need to insert the information. Maybe the information is not inserted, so it is not showing me the relation. But for the first clause, it has shown the relation. So we are getting the information displayed over here. So the match clause is important to get the information from the graph database. So we have executed these set of statements and seen how the graph database is getting maintained. There are three things which we need to keep track of. While creating the database, we can create the graph database. We can add nodes and edges to it. These are simple tables which are added as nodes and edges. And in the edges, we are actually specifying the relation between the two tables, what attributes are mapping to other attributes of the other table. Now to visualize this, we have other tools available. One of the tools is the Python library, which is NetworkX. Let me just brief about how we can use the NetworkX library of Python. Is my screen visible? So here you can notice that we have import statement, import network X as NX and matplotlib to plot the graph. In case if I'm not using this, it will work because network X has the capability of plotting the information. I'll not be using the plot, but I'll just be using the draw statement for draw function for displaying the nodes. So here we have the graph object created as G. We have added 3 nodes and there is a color attribute which is mentioned to the nodes. We have mentioned the edges. The most important thing for a graph database or a graph object is the nodes and edges, and that relation has to be defined, predefined. So here we have added certain nodes and added edges to the graph. Node A is pointing to node B, node A is pointing to node C, and we have a from and to relation existing between node B and node C. And to draw this particular graph, we have the nx.draw. You could notice that we have the graph appearing on the screen. So we have the graph, node A is pointing to node C, node A is pointing to node B, and node B is pointing to node C. In case if I don't specify the last relation, let us see what type of graph we are getting or what is the graph displaying us. So here we have A related to C and A related to B. There is no relationship between B and C. So let me add a few more nodes to this. And specify the relation as well. A is related to B. B is related to B. some relations has been stated here. So let's see. So this is a graph which has been plotted for us. So node A is related to node B. Node A is related to node C. There is a relation from node A to node E. We have B and E. No relation is there between B and E. D and F, we have a relation here. D and F and E. Suppose I add a new relation, D and C. So the graph will be displayed as per the relation we had created. The input to the graph could be taken from CSV files from multiple sources. We could also take the input to the graph of network X from the XML files, graph ML files. So we can take the use it in any of the data sources. Here we have plotted the static content, static edges and nodes, which we are mentioning in this particular graph plot. Now this is one of the visualization tools. So once you have your relations, once you have the data created, we can use any of the visualization tools. We may also, in this particular graph, we are just using the labels on the edges. We can also, on the nodes, we can also use the labels on the edges, which are displayed here. So to specify the relation created. I hope this is clear.
You can leave your comments in the comment box, chat window. Any queries or any comments can be left in the chat. Anyone with any queries or anything, you can just put up your messages in chat window.
Okay, next we are moving towards the big data tools and technologies. There are other tools and technologies which are there for representing the graph database and processing the graph information. So we have big data analytics has evolved since the early 2000, which the creation with the creation of technologies like Hadoop, Spark, NoSQL databases. The field continues to evolve with emerging technologies like machine learning. Big data analytics is the process of analyzing large volume of data to cover to uncover patterns and behaviors. There are many tools and technologies used in big data analytics, including data mining, AI, predictive analytics, machine learning, statistical analysis, and so on. The process of big data analytics involves collecting, processing, cleaning, analyzing large data sets to help organizations make data informed decisions. Apache Spark, we had just mentioned, is one of the technologies we are working on. Apache Spark is an open source big data processing framework built around speed, ease of use, and sophisticated analytics. It was originally developed in 2009, and the open sourced to Apache project in 2010. Spark enables applications in Hadoop cluster to run 100 times faster in memory and 10 times faster even on the when run on disk. Spark gives us a comprehensive unified framework to manage big data processing requirements with a variety of data sets that are diverse in nature: text data, graph data, etc., as well as the source of data like batch versus real-time streaming data. Hadoop Spark, Hadoop as a big data processing technology has been around for 10 years and has proven to be a solution of choice for processing large data sets. MapReduce is a great solution for one pass computation, but not very efficient for use cases that requires multi-pass computations and algorithms. Spark allows programmers to develop complex multi-step data pipelines using directed acyclic graph, that is DAG pattern. It also supports in-memory data sharing across DAGs so that different jobs can work with the same data. Spark runs on top of existing Hadoop distributed file system, that is HDFs, infrastructure to provide enhanced and additional functionalities. It provides support for deploying Spark applications in an existing Hadoop clusters. Hadoop components can be used alongside Spark in the following ways. HDFs. Spark runs on top of HDFs, that is Hadoop file system, to leverage the distributed replication storage. MapReduce. Spark can be used along with MapReduce in the same Hadoop cluster or separately as a processing framework. Yarn. Spark applications can be made to run on Yarn, Hadoop next generation. Then batch and real-time processing. MapReduce and Spark are used together, where MapReduce is used for batch processing and Spark for real-time processing. Now we have various components of Apache Spark. We have Spark Core, the core libraries, Spark Streaming, Spark SQL, Graphics, and MLib. MLib is machine learning libraries. So here we will be discussing the framework, the component, graphics component, which will be used for processing the graph data. Spark is written in Scala programming language and runs on Java virtual machine environment. It currently supports the following languages for developing applications using Spark. We have Scala, Java, Python, Clojure, and R. Spark Core is the base engine for large-scale parallel and distributed data processing. The core is distributed execution engine, and Java, Scala, R, and Python APIs offer a platform for distributed application development. It is responsible for memory management and fault recovery, scheduling, distributing, and monitoring jobs on a cluster, interacting with the storage system. Spark Streaming is a component of Spark which is used to real-time streaming data. Thus, it is useful additionally to the core Spark APIs. It enables high throughput and fault-tolerant streaming processing of live data streams. The fundamental stream unit is dstream, which is basically a stream of RDD. Resilient distributed datasets to process the real-time data. The real-time data could be generated from any of the data sources, any of the sources. We have Twitter, we have stock markets, we have weather forecasting. It could be any source from where the data could be generated. Now, moving on to graphics. Graphics is a Spark API for graph and graph parallel computations. Thus, it extends the graph RDD with a resilient distributed property graph. The property graph is a directed multi-graph which can have multiple edges in parallel. Every edge and vertex have user-defined properties associated with it. Here, a parallel edge allows multiple relations between the same vertex. At the high level, GraphX extends the Spark RDD abstraction by introducing the resilient distributed property graph, a directed multi-graph with properties attached to each vertex and edge. So we have been hearing this term many times. So RDD is a resilient distributed dataset. Resilient distributed dataset or RDD is the core concept of Spark framework. Think about RDD as a table in the database. It can hold any type of data. Spark stores data in RDD on different partitions. So the important point is it can store data on partitions and it can hold any type of data, whichever the user needs to store. They help with rearranging and computations and optimizing the data processing. They are also fault tolerant because RDD knows how to recreate and recompute the datasets. RDD are immutable. You can modify an RDD with a transformation, but transformation returns you a new RDD. So it will be a new instance of RDD which will be created. RDD supports two types of operations, transformation and action. Transformations don't return single value, they return a new RDD. Nothing gets evaluated when you call a transformation function. It just takes an RDD and returns a new RDD. The action operation evaluates and returns a new value. When an action function is called on a RDD object, all the data processing queries are computed at the same time and the result value is returned. Some of the action operations are reduce, select, count, first, take, count by key, for each, and so on. So, action will be performed on the pre-created data which we are passing to the RDD. Now, there are certain functions which are which I would first like to reference and then give a practical application of how we can actually create a work on the graph data. So we need to first install Spark. After installing Apache Spark, we will be creating or initializing the shell wherein we can process the information. So we need to import certain libraries. The libraries are import org.apache.spark, org.apache.spark.rdd, util, graphics, and graph generator. The value we are passing here, we are creating a person object comprising of certain values. It includes the ID, name, and age attribute. In the array, I have included the ID, name, and age attributes. The array could be also replaced by any of the data sources. We could pass a CSV file, we could pass a JSON file. Any of the files could be passed to and created. The object could be created. Once we are processing this particular statement, it will create a person object with the values stored here. It has already specified array comprising of a long as the first ID parameter, name a string parameter, and age integer parameter. Again, a relationship array has been defined wherein we are specifying the edges, the node ID linked from node ID to node ID. What is the relationship we are mentioning here? Once the relationship is created, the array, the object will be created. We may process this data and get the required information, whichever is required for us. So we have created the nodes and we have created the edges using these two objects. We have the person and relationship object created. So let me first run these queries, these statements, and check if it is working. For working on Sparks, I have configured the virtual machine and installed CentOS 7 on it. So the first command, firstly we need to install the Spark. I will be sharing the link on how we can configure the virtual machine on a Windows machine. Which image file needs to be downloaded to configure the CentOS? What all commands are required for installing and what all libraries are required to be configured before we start with the Apache Spark. I'll be sharing a link for that. So once my Spark is installed, we will be initiating the Spark shell. By default, it will be coming to the Scala prompt once the application is initiated. We have PySpark and Apache Spark. Both we can work with the same set of libraries. PySpark will be providing you with a Python platform, and Spark Shell will by default be pointing to the Scala. So here, as I have already stated, we need to download, we need to import certain libraries. Update from here. So these are the libraries which we have imported. Next, the array. We can add new data to it. So you will notice that it has created an array object with 3 parameters. The first one, a long of type long, second string, and third an integer. Similar to this, we will be passing the edge also. So we will create the relationship array. Creating the RDD, person RDD, and relation RDD. The graph object created. So we have accessed the information from the object, the graph object here, wherein we are able to represent the information and display the values here. So you could notice that we are able to successfully fetch the information from here. So as per the relation we had seen, we had created the nodes as ID 1 Andrews, age 45. 1 is related to 2 as husband. 1 is related to 3 as father. 1 is related to 4 as father. 1 is related to 5 as friend. 1 is related to 6 as friend. 2 is related to 1 as wife, and so on. So let's see the representation. We are able to derive it here or not. So here with this statement we conclude Andrews is related to Celia as husband. Andrews is related to Bob as father. Andrews is related to Emily as father, and so on. So we are able to successfully fetch the information from the nodes and the relating it to fetching the relationship from the edges object here. Similar to this, we have other nodes and edges which are successfully fetched, and the information is getting displayed. We have other operations also, and Apache Spark does not provide a graphical view of the graphs, but it has the power of processing the graph information. I hope it was clear. I will be sharing these commands, these files, and these the links, the sources from where I had taken the reference from. Any queries?
Any queries?
So here is a use case getting displayed, wherein we have a huge amount of flight data being analyzed using Apache Spark. The problem statement is to analyze real-time flight data using Apache Spark graphics, provide a near real-time computation result, and visualize the result using Google Data Studio. So as I had already mentioned, that Spark graphics is not having the data visualization. We can visualize the data using the Google Data Studio. So the use case computation to be done is compute the total number of flights, compute and sort longest flight route, display the airport and the highest degree vertex, list the most important airport according to page rank, list the routes with lowest flight cost. So this is one of the use cases which was mentioned, and the steps which are used for processing this information. So firstly, we need to collect the flight data. That is a huge amount of data being generated. The data is stored in real-time flight database. From there, creating the graphs using the graphics. Apache graphics is used for processing the information, computing the values, and then visualization of the flight data could be done using the Google Data Studio. Okay, with this, I conclude with the presentation. Any doubts? Any information required? Thank you all.
Any doubts, anything?
No.
Thank you so much, ma'am. It was really very knowledgeable. Yes. Surely this information would help everyone for real-time analysis, and we would surely have many different results from it. Thank you so much, ma'am. Thank you so much, everyone, for joining us. We'll be back tomorrow with another knowledgeable sessions by Dr. Anu Taneja on data processing using Python. Both the sessions will be completely, or session one will be a processing session using Python, and the other would be your statistical analysis using Python. So again, joining up tomorrow at 9 o'clock. Sorry, at 10 o'clock. Thank you so much, everyone. Have a nice day.
Thank you, Sonia.
Surely we would like to have a sort of feedback from you all in the chat window. Thank you so much.